So now we have a function that's just defined by a graph, not defined by an equation, and I want to find the inverse of it. Well, to find the inverse of the function, I need to know what the points along the function are. So we have 6 points along the function. I'm going to actually have to list them out. First point would be at negative 6, 4. Next point's at negative 4, 6. 0, 6. 2, 2. 4, 2. And 6, 0. And I went left to right just to make things easier when we actually go to create the inverse, because the order that we connect the points in will matter. To get the inverse, we flip-flop the x and y coordinates. So negative 6, 4 becomes 4, negative 6. We then get 6, negative 4. 6, 0. 2, 2 actually won't change because the x and the y are actually the same coordinate. 2, 4. And 0, 6. We're going to have to graph these on. Some of them we'll have to estimate because the graph doesn't go quite far enough as we need. I'm going to start with my first point, 4, negative 6, roughly about there. 6, negative 4, and I'm going to connect these as we go just so I don't lose track of which point is which. Another point at 6, 0, 2, 2, 2, 4, and 0, 6. One more time. Now what you should hopefully notice is that the inverse graph is actually similar to the original graph. It's been flipped and reflected a little bit differently than what we've dealt with in the past, but it is still the same shape. Question B is asking for the domain and range of the relation and its inverse. Now if we deal with the original function, the domain, the x's, go from negative 6 to 6. Which, if we relate in inequalities, is going to be the most efficient way of doing it. X is between negative 6 and 6. The range, the y's, anywhere from 0 to 6. With the inverse function, the domain is not the same because the inverse function only goes from 0 to 6 on the x-axis. The range is also not the same, but this function goes from negative 6 to 6 on the y-axis. Now if you look and you compare the domain and range for each of the functions, you'll find that there should be a relationship between them. The domain of one is the range of the other, and vice versa. Which should make sense because we interchanged x's and y's, so we interchanged the domain and the range.